Hello, this is Brother Tony. The purpose of this recording is to give you a little bit of the theoretical background that you'll need for this activity. By now, before you look at this recording, watch this recording, I recommend that you have read pages 1 through 10 of Activity 1 and taken notes to get the definitional terms down. For the rest of this quarter, we will be talking about bridges, designing a bridge, analyzing a bridge, and doing some mathematical analysis. Now, one of the things about bridges is they're designed not to move, and that's called the static design. What we want to be able to do is provide and analyze these bridges statically to see when they would fail. So here's a little bit of background. What you'll see is a drawing here. So let's start out saying we just have a one-member bridge. This long piece is one member. Now, what you'll see in the future, on the left-hand side of that triangle, that's saying that's being pinned to the bank, meaning it would not move right here. That's solid. On the other side here, that's actually a roller, and that allows the bridge to move just slightly, and it allows our analysis to be much easier. Now, the idea of a bridge is to say the sum of the force in the y direction means that it's 0. The sum of the forces in the x direction must equal 0. And the sum of the moments must equal 0. So meaning, if that's the y direction, that if a car goes over and the car has mass and gravity is pulling it down, the bridge must resist a downward motion and be able to stay upright. So the sum of the forces is 0. Same thing in the x direction. If something pushes against it, the bridge would push back. Sum of the forces in the x direction would be 0. And the sum of the moments. Now what a moment is, it's very equivalent to torque. It is some force acting at some distance. Torque is F times D. In our examples, we'll see that the moment is some sort of force times R. Okay, here we have a single member bridge. And this member is staying upright, it's not moving. Now what's opposing it? On the earth, any place where there's mass, there's gravity. So in essence, gravity, the force of gravity is pulling down this member, trying to pull it into the earth. What opposes it? Because what we're saying here is in order for a bridge to stay upright, the sum of the forces must be 0. So we have a force going down, that's gravity. We must have something opposing it, equal but opposite direction. And what that is called is the normal force. This normal force opposes the force of gravity. And the normal force is from the component that makes up the bridge, the material, the steel, the wood, etc., that makes up that member right there. But if we go beyond that, if we take a look at the physics of it, the normal force is in physics what we call the electromagnetic force. Okay. When elements bond together, when elements create compounds, the electrons interact to bring this together and actually have a resistance to being broken apart. So when you sit down in a chair, when the chair is empty, that normal force, all that normal force is doing is reacting against gravity for the actual material of the chair. However, when you sit down in it, then the electromagnetic force also is strong enough, hopefully, to keep the chair at a static, as well as to take your weight. And it will do so until it gets overweighted, and then it collapses. So what I want you to remember from this slide is that the sum of the forces in the y direction especially, anything pulling down due to gravity, will be counteracted by the normal force going up. And the normal force The physical term, the physics term for that, is the electromagnetic force. So we have a static structure here. Let's take a look at the one on the left. Now the force of 10 kilograms is going straight down. Now this structure here, the member, has to have what we would call a reaction. The reaction is equal and opposite, and that has to be 10 kilograms straight up. So the sum of the forces would be, if we want to say that in the y direction, that's the positive. The force resisting it is 10 kilograms. The weight of the mass is a negative 10 kilograms. That equals 0. Hence, the sum of the forces in the y direction is 0. Now, let's take a look at the right side here. We have two beams, and pretend, I'm a horrible drawer, so just pretend that these beams, these members, are the same size. And this 10 kilogram mass is being distributed equally through the members. So what we would have here is we would have the 10 kilograms distributed equally 5 kilograms to this side and 5 kilograms to this side. Okay. Now, the reason that I don't say that this beam right here is taking 5 kilograms, because actually it isn't. We would have to do right angle trigonometry right there, and we would say that the 5 kilograms would be distributed in the y direction there, and the same thing on the other side. We could not with accuracy say that the 5 kilograms is on the hypotenuse. We can with accuracy if this 10 kilograms is being equally distributed, saying 5 kilograms is going down, is distributed to one side and 5 kilograms to the other. For now, just know that we generally deal with more than one member. Why? Because in the y direction, a single member is fine. But if you have just a little push in the x direction, the whole thing will topple down. Whereas if you have two or more members with the distribution of weight, if you go in the y direction at any point, it becomes more stable and is not and has resistance to collapsing. Okay, the purpose of a bridge is to transport something across a bridge. So there's going to be a load on it at some point. Anything that's not part of the bridge we'd call an external load. And the loads will be distributed. The bridge is going to stay up. The loads will be distributed and be counteracted either due to the tension or the compression of the members of the bridge. So on the left-hand side, what you have here is an example of compression. So I have my weight right there, and I have two members, one on the left, one on the right, and the load is pushing down with gravity. The members are actually compressing. They're being squished together, but they have enough normal force that by compressing it resists the load going down and keeps it in equilibrium. Now looking over here on the right hand side, we would have this member on the left, this member on the right, with tension. The load is trying to pull the two members apart. The normal force keeps it in equilibrium, but there is tension on those two members. And what we're going to see is when we do the analysis is we'll have one type of load, compression or tension, be the positive, and the other one be the negative. Thank you for your attention during this short video. Now when you come in for the class, there's going to be a short quiz, and from this video you should be able to answer what are the three forces that the sum of the forces have to be equal to zero in order to have that bridge being stable. What is the name of the physical force that resists a load? And it's not that we call it the normal force, but there's a physical definition, the physics term for it. If I give you a load and a couple of members, you'll be able to draw the reactions on those members. Then also to be able to tell if a member or members is under tension or compression. That's what you should have gotten out of this video. If you didn't, please go and review it. Also from the reading, I'm going to quiz you on some definitional terms. So any of those in black or bold, you should be prepared to answer. Okay, see you at next class.